Hello and welcome on our sixth meeting of our CKAD study group. I hope you like it so far, and I hope you will like on this meeting as well. So what's in our plans for today? The plan is simple, but first I introduce myself for people that are watching me for the first time. So my name is Łukasz Tomaszkiewicz, but you can call me Luke Tom as well. And I help developer and DevOps engineers to accelerate their career in the cloud. And I do it in a couple of ways. I run YouTube channel both in Polish called Kursy Cloud/YouTube, as well as Luke Tom Cloud/YouTube, which you are watching right now. Please don't forget to subscribe to the channel and give the thumbs up, because it really helps me with YouTube algorithm to get more views. What else I do? I create online courses. So far I created course Terraform.pl, which is about leading tool for infrastructure provisioning with infrastructure as a code approach. And I also created the path of the AWS developer. Both of them are in Polish. And if you are talking Polish, I highly recommend checking them out on kursy.cloud. I also run on-site workshops, so if you or your company are interested in having something related to cloud or something related to infrastructure automation, then you can invite me and we can make a workshop on-site. I also work as a senior cloud infrastructure architect at AWS, and yesterday it was actually my second anniversary working there. Okay, and let's go to today's topic. Maybe not straight to the topic, but first to the calendar and agenda. Just to remind you, we are meeting every Thursday at 5 p.m. UTC time, and so far we've got a couple of meetings. Today one is about application environment configuration and security, and then next week we are starting with next week there will be the last regular meeting of our study group, and somewhere in the middle of the next week I hope to create and invite you to a Q&A session. I planned to do it this week, however I got sick at the beginning of the week. And then I hope you will easily pass the exam and share your results with me, because it will be I will be very happy if you succeed with my little help. So today is application environment configuration and security, and there are a couple of topics for today. So actually we will start with discovering and reusing of Kubernetes cluster resource definitions. Then we will move to authentication, authorization, and admission control. Then we will go to something related to feature, to requirements, to limits, and to quotas mechanisms. We will skip two topics from that domain because I already covered that during the third meeting. If you don't remember what are the config maps or how to create and consume the secrets, then I highly recommend you to go to luketom.cloud/YouTube, and then on the live tab you can find all the recordings from our CKAD group, and then on the third recording there is a chapter dedicated for that special thing. And then last thing for today will be service accounts and security context. I talked about that a little on our second meeting. However, we will go again through that topic with more details today. So as you can see, there are a lot of topics for today, so let's get started. So first topic is discover and use resources to extend Kubernetes. First, let's answer the question, what are the custom resources? What's their role? What's their purpose? So basically, it's a way to extend Kubernetes API. And by extend, I mean you can add additional functionality that looks like Kubernetes built-in. You are basically running the same commands, but with different parameters. And you can, interact with the Kubernetes the way you know already. Basically, this is not the only way to extend the Kubernetes. There is also something like API aggregation, which is kind of different. It is kind of proxy that you can implement on Kubernetes, but this is outside of the scope of the exam, so we won't cover that today. We will focus only on custom resources. So basically, when you create a custom resource definition in Kubernetes, there is a new API created, a new endpoint created on the API server. So basically, you can query for your custom resources created based on that custom resource definition. And what's the use case? They usually represent some kind of domain-specific objects of applications. The best example, I think, are the certificates. So you can, for example, install an application called Certificate Manager on your cluster, and it adds a couple of additional objects like certificate, like certificate request, like issuer and cluster issuer. And all these objects you can create and interact with them in order to get some kind of new functionality, new features. In case of Certificate Manager, you are getting just, TLS certificates from Let's Encrypt. So you've got encryption for free, basically. Custom resources can be used in a couple of ways. One of which is just to store some kind of information. If you need to, structure information in any way and store them in Kubernetes, it's perfectly fine, to just store your data inside the Kubernetes. However, be aware about the limits, because at CD, the database that's running Kubernetes, that's running under the Kubernetes, it's limited to 5 megabytes per item, if I remember correctly. So be aware that there are limits on the storage over there. So this is one case. However, the more common approach is that the custom resources you are creating are actually watched for and observed by some kind of controller. So what is the controller in that context? This is simply an application that constantly monitors the Kubernetes and watches some of the resources and then reacts to them in some way. In our example of Certificate Manager, it watches resources like certificates. So when you are creating a certificate, it sees, oh, there is a new certificate in cluster. Let's issue an actual certificate for that object in Kubernetes. So basically, controller is some kind of design pattern, some kind of part of the application that runs in something called controller loop to monitor the resources and react accordingly. Custom resources can be also used as some kind of abstraction over the other parts of infrastructure. For example, in Kubernetes, there is something called operator pattern, and operator pattern is about configuring applications using custom resource definitions. What are the examples? For example, we've got Prometheus, which is a leading tool for monitoring metrics on the Kubernetes cluster. And you can, of course, configure configure Prometheus from ground up, using Helm charts and providing values by yourself. However, it's usually much faster and less error prone to use something called Prometheus operator. And basically, by installing that operator, you just need to create a custom resource in which you are telling that I want Prometheus, and then that operator introduces all the necessary resources for you. So actually, that custom resource is an abstraction of the broader application and many resources that are created. What is very important about custom resources is that they are managed in the same way as built-in resources. So you don't have to, have some kind of new API. You don't have to use new tools to manage them. If you are, familiar with kube control or K9S, it's perfectly fine for most of the cases to interact with custom resources. And last but not least, that way of managing resources is also related to role-based access control, which I'm going to describe at the end of today's meeting. So let's move forward for now, right now. I've got a sample custom resource definition from you. This is directly from Kubernetes documentation, and let's see what's here. So basically, that's kind of beauty of Kubernetes that you've got kind of recursion here. So basically, we are creating a new kind of resource using the resource called custom resource definition. So, we are using the same structure for creating new objects in Kubernetes. So this is, kind of beautiful, and I really like that approach and that design. Just see how scalable it is. Okay, then we've got something called name. This is the name of our custom resource. It should be unique across the cluster because in other cases there will be collision and you can get unexpected results. However, there are a couple of things in that design which are also, I think this is very good example of design and thoughtfully process for managing that design process. We've got something called group, and group is basically for creating namespaces for custom resources. So as you probably used to, we always need to specify API version, and that API version, as you saw at the beginning, has a group at the beginning over there. So this is basically the group. And the second thing is the version. So basically you can specify both the group. For example, the group can be namespace for your application or for your company and application or anything you like. Just make sure that this is unique. And approaching the things with domains is usually a guarantee of being unique. This is something similar to Java namespaces. And then we've got another thing here that we can distinguish versions of our custom resource. As you can see, there is a list of versions and we can name all the versions over there. So basically, if we need to upgrade our custom resource definition in the future, this is already supported by Kubernetes and is included in the current version of design. Two things here. Only one version can be marked as the main one. Other ones are just, for compatibility reasons. There is a point called schema here and property called schema here. And as you can see from the name, it uses Open API specification in the version 3. And here using YAM, you can describe your object. And by that, I mean all the properties it can have within the spec, or maybe in other properties of that tree. And you can also type them. I mean, you can indicate that this is, for example, an object, this is a string, integer, and other stuff. And this is very nice that Kubernetes will do a basic validation for you. So you know, in case you provide integer into the string, there will be an error or just an automatic conversion. It depends on the case. But there's some kind of basic validation is provided to you, for free as a feature of Kubernetes. Then we have something that is called scope. Scope can tell Kubernetes if the custom resource is namespaced or cluster level. So basically, if something is at the cluster level, it's created globally across the cluster, and usually you need to apply with other permissions to that object. On the other hand, if something is namespaced, it's kind of local, and you can limit and allow only the specific users to create specific objects in specific namespaces. We'll talk about that later. Then we've got a couple of nice ways to describe our things, our custom resource we are creating. The most important is, of course, kind, because it will be used in our manifest in Kubernetes. But we can also provide a couple of additional things like plural and singular form of our resource. And there is also something called shortcode. And here we can provide a list of aliases, a list of shortcodes that we can use across all the commands in Kubernetes. So basically, if we were to get that kind of resource to our cluster, we can just do, cd, and it will be just fine. Okay, let's go to sample custom resource that actually fits to previous example. So as you can see, we are using API version that was specified in the custom resource definitions. We are using a kind we specified on the previous object, and then we are providing a spec here. So as you can see, it's all according to the specification. Maybe let me move that a little bit. As you can see, there is a specification, and there is an implementation of that sample object. How deployment of that looks like? As you can imagine, it's very simple. You just save that to some kind of file. Maybe let me go to my Kubernetes, to clusters, okay, CKAD, and here let's create a new object called myCRD, cut to YAML, and this way I will paste that. Press Ctrl D to save that. As you can see, there is an object like that, and then I can follow with the typical approach. Cube control apply from file my custom resource definition. Okay, boom. And as you can see, it's created. So now I can do cube control get CRDs, and I should see my custom resource definition over there. And as you can see, it's here, just created, ready to be used. And so basically, if I of course forget to switch the screen. So let's do it again. I need to, put some kind of sticky note on the screen, so I remember about that. But maybe next time. Okay. So let me do it again. So I'm here in my console. I'm saving that to the file. Just pasting, again, I need to copy that and then paste it to the file. It was written to the myCRD, and then let's apply that to my Kubernetes cluster. This is, the typical flow of applying things to Kubernetes. And now I can go do kube control and get custom resource definitions. And as you can see, the thing that I created is over there. It's, created a minute ago. So this is how you apply and create custom resource definition. But if I want to use it, I need to copy the second example from my presentation. So as you can see, I need to copy that. And then let's call it use. Save it, and also I've got a quick alias kube control apply from file. It's quicker to write KAF than kube control apply F, and I highly recommend you to create aliases at the beginning of your exam, so you don't have to type over and over again the same things, because it's just insane to type the full commands. And now, as you can see, I've got something like that. I can now get objects of my name of my custom resource definition. And as you can see, I used my alias. So if you remember, in my CRD, I created a shortcode here called CT, and then I can use that CT to just get things like that. And as you can see, I've got that object. So I can also output that as YAML, so you will see the details of that. And here it is. Here is my object that I created over there. Of course, the object will be visible in K9S as well. You can just type colon and then custom resource definition, and you can see that we've got all the things related here. And here is my example. However, I'm not sure why describe and YAML doesn't work here. I'm just pressing Y, but it's not working in K9S, so be aware about that. But the nice thing is that if I press enter over there, then I moved to the filter with all my cron tabs. So as you can see, I can list the objects I created. And here, all the commands from K9S works just fine. So I can, I can just go here and see all the things for my object. So this is kind of nice. Of course, when I delete the custom resource, something is not working. Boom. Probably I need to delete that from the command line, because as I mentioned before, KNLS is not working correctly with custom resource definitions. I've got something called KDF. It's alias for kube control delete from file. Maybe for being clear, I will write full command over there. So it's kube control delete -f and then my CRD. And as you can see, it was deleted. And now if I get to, if I want to go and get my resource, you can see that actually it's not available anymore. So by deleting my custom resource definition, I also deleted all my custom resources. So be aware that if you delete the custom resource definition, all the things across, all whole cluster will be deleted as well. So that's the thing that you should be aware of. And as you saw a minute ago, there are many custom resource definitions here in my cluster. Maybe not many, but a dozen or two dozens. And as you can see, they are from different sources. For example, this is from CKAD.io. This is from provider of that cluster, as well as I've got Flux CD here, and you can see that I've got multiple things related to that specific product, to that specific application. And as you can see, this is kind of nice, because custom resources can be customized in the way that, for example, they by default show some kind of columns here in K9S as well as in the console, and they usually can give you also some kind of status, for example, for reconciliation here of Helm charts. So this is kind of nice, and it's really a pleasure to working with custom resources in Kubernetes as a comparison to other extension mechanisms. I think it's just perfect, and I really like it. So this is related to custom resources. Let's move to the next topic in my presentation for today. Of course, if you've got any questions, just let me know, and I will try to answer them during the break. So next topic is understand authentication, authorization, and admission control. There are three topics over there. I talked already a week or two ago about admission control, and this is about mutating webhooks and validating webhooks. So if you don't remember that, I highly recommend to watch again one of the previous videos. Today we will focus on authentication and authorization, because this is broad topic and we have finite amount of time, unfortunately. If you don't remember, authentication is about determining who you are. So this is about identifying who you are and then checking some kind of things that you can prove that you are you. And authentication is usually performed with login password. So there can be two-factor authentication that you need to provide two factors, as the name suggests, to prove that you are you. And this is all about identity. On the other hand, authorization is about determining what you can do, or to be more precise, what identity you proved you are can do on some kind of specific resource. So this is all about allowing or denying access to some kind of resource. And of course, I've got some issue with my presentation over there. Unfortunately, I created that. Fortunately, I create that in Markdown, but if I forget to type and I type additional space between the slide, it breaks and shows like that. So there are two account types in the Kubernetes cluster. There are normal users as well as there are service accounts. And let's start with normal users. That may be a surprise for you, but Kubernetes actually does not have any kind of objects related to the users. There's no way to represent a user inside the Kubernetes. Kubernetes has no clue, no internal database of the users that can access the cluster. So that's usually surprising for people approaching Kubernetes. It also doesn't have any kind of concept of username. There's not a list of usernames in Kubernetes. So how users are identified? And they are identified, for example, using certificates or maybe a J token, JWT. It's probably called pronounced as J. I don't know why, but I checked that before today's meeting, and it's pronounced as J. And last thing is that user is kind of cluster level resource. I'm telling resource because, you know, this is not actually resource that you can create in the cluster, but it's considered, you know, at the cluster level. So it's not tied to any kind of namespace. On the other hand, we've got the service accounts. Service accounts is for workloads. So they are not for humans, not for applications, external applications. They are only for workloads running in pods. So this is more internal to the cluster. They basically not only provide the identity for the pod, but also allow to use that identity to connect to a cluster API server. So in case your application needs to, you know, get some kind of information from the cluster, it needs some kind of identity for API server. I created one application on the Kubernetes that actually, you know, provisioned infrastructure based on the custom resource. And it was very nice because, you know, we just gave the permissions to access a specific custom resource. And when operator created that custom resource, the application, you know, provisioned the whole infrastructure in AWS based on that. So that's kind of nice thing. Service accounts are typical objects in Kubernetes. Moreover, they are namespaced. So basically, if you are creating a service account, the service account belongs to the specific namespace it was created in. And because of that, we can consider service account portable. So basically, you can, you know, put that service account in some kind of YAML manifest, you know, pack it in the Helm chart and publish, and then someone can reuse that easily because it's quite portable. On the other hand, if you want to provide something like, you know, authorization for the user, it's not that portable because, you know, it depends on the configuration of the cluster. It depends on the factor that user uses for authentication. So normal users are not portable, but service account are. And what is more important about service accounts, they have something called token, and the tokens are saved in the secrets. It's sometimes useful to know. As you can see, the service account is quite simple to create. We just need to specify an append manifest with the kind service account and just provide a name. And of course, you can provide an optional namespace. In the case that you see on the screen, it will be creating the default namespace. But of course, in the metadata property, you can specify the namespace for that. And now let's go through authentication methods for Kubernetes. So actually, what are the ways to prove your identity? First one, and probably one of the most common, is X509 client certificates. It sounds scary, but this is, you know, just a typical TLS certificate that you use every day, but in the server fashion. You know, you are using that certificates wherever you are using HTTPS. But there is a special kind of certificates that you can also issue that are called client certificates, and they are here just to prove that whoever has that certificate has some kind of access and has identity that can be verified by the cluster. Second thing is static tokens. They are usually used for things like bootstrapping the cluster, or maybe it was used a couple of years ago in a Kubernetes dashboard as one of the ways to authenticate. I don't recommend that. I mean, especially for production use. Then we've got a service account token. So basically, if you create a service account, there is a token generated for them. There's a, you know, dedicated controller inside Kube Controller Manager that creates random token for service accounts, or of course signed properly. And this way, we can authenticate our pods to cluster API using that tokens. Then we've got bearer tokens. Bearer tokens are basically the tokens that you are, you know, putting inside HTTP authentication header. This is especially useful when you have some kind of application that integrates using that method. And then we've got a very related topic. This is OpenID Connect token. So this is actually part of OAuth 2. If you are familiar, you know, with concept of federated authentication using OAuth 2, and then the part of that, or maybe just the part related to identity, is something called OpenID Connect. You probably also use that every day. For example, if you are logging to any application using Facebook or Google account or Microsoft account or Apple ID or however it's called, and then you are using OpenID Connect underneath, and there is a token involved somewhere over there, and you can use the same method to access Kubernetes cluster using that. And from my experience, it's one of the most extensible one, and also quite simple one to integrate, as long as you are familiar with OIDC concept. I highly recommend this approach because you can use that tokens not only to authenticate to your cluster, but you can also use them to authenticate to the applications you've got on your cluster, like Grafana, Prometheus, and other stuff. Sometimes you need to use a proxy, but that's other thing. For example, Grafana supports it out of the box, so it's quite nice, you know, to use and have, you know, a single sign on and then just reuse that tokens. And there are other topics and other authentication methods you can use, but there are, you know, some kind of minor. For example, you've got node authentication, which is used by kubelets. I mean, the processes that are running Kubernetes agents on the nodes to authenticate that kubelets to the cluster. So this is basically it regarding authentication. And how you can check how you are authenticating to your cluster. That's simple. You just need to issue a command like that, kubectl config view, and it will output something like that. This is a redacted form. I mean, for example, it doesn't output things like actual certificate or key data, so it is quite safe to use even if someone watching behind your arm. On the other hand, there is also a way to you know, just put row or output YAML and then output the complete file, config file. And what we have here, first in kubeconfig we can find a block or a property called clusters, and there's a list of clusters over here. And you can see there are two important things here, other than name, of course. There's a certificate authority data, and this is some kind of certificate that is used to authenticate the cluster for use, so you are sure that you are connecting to the proper cluster. And this is to prevent man-in-the-middle attacks. And then you've got a server URL using that IP, your kubectl, as well as other tools that you are using are locating the cluster. Then we have something called context, and context is basically a kind of binding objects between the cluster and user you are using. I will go back in a minute to that. And finally, we've got users here. So basically, there are a couple of settings you can provide here. The example here uses a client certificate. So I've got my certificate pasted over there in the original form. However, there are other things. For example, for using EKS, you can use a configuration that executes external process that authenticates you with AWS. It's kind of crazy stuff. And there are, you know, a couple of approaches here, and I saw, for example, also static tokens in some cases, and it's quite common. So basically, you can use one user of, if you've got, you know, certificate that is signed, for example, for your company CA, your client certificate, then you can maybe authorize to multiple clusters. And in order to allow you to connect to multiple cluster, there is something called context, and context is basically a binding between configuration of the cluster and configuration of your user credentials. So basically, if I had a couple of clusters over there, I can reuse my username and my certificate, you know, so I don't have to repeat over and over myself within that config file. So this is working like that. Maybe it's not, very useful in case of certificates because it's just copying. However, if you are using external processes like, logging for EKS and other stuff, it may be useful because then this way you don't have to, sign multiple times just to access multiple clusters. So you can reuse that user credentials. Okay, so we covered authentication methods. Now it's time for authorization methods. There's authorization method of known. If you are, for example, developing something or don't want any kind of authorization and just allow to do anything, you can disable authorization. There is something called attribute-based access control. It's all about writing some kind of policies that allow you to perform some actions based on the attributes that you have provided to the cluster. It's not very popular, I can say. And I think it's not deprecated, but it was used in the early stages of Kubernetes, if I remember correctly. Then we've got something called webhook. So basically, you can provide a webhook URL to the Kubernetes API server, and it will use that webhook for authentication. So you can write external application outside of the Kubernetes cluster, and then that application will authenticate or just deny authentication for your application. So this is quite nice in terms of extensibility. And then we have something that is most popular in Kubernetes. It's called role-based access control, and we are going to talk about it a little more in a minute. And finally, there's one more, and there is a node authorization, that allows nodes to perform some actions like creating a node object inside the cluster or updating metrics and doing other stuff that nodes are usually do. Okay, let's go to the role because it's kind of important thing. First, you need to know that there are two kinds of roles. There is a role that you are seeing on the screen, and there is also something cluster role. The only difference here is that role is namespace, so it's local to the namespace. On the other hand, cluster role is something that is cluster wide and and it's not applied to the specific namespaces. So as you can see here, we've got the typical metadata for Kubernetes, and here we've got something called rules, and this is the most important part of the role, as it tells Kubernetes what is allowed for anyone that can use that role. As you can see, there is no allow or deny. Kubernetes is deny by default, but allow only when the rules are matched. And there are a couple of things that you need to specify here. First one is API group, so it matches, API version and other stuff. Then we have resources. So for example, here we are creating a rule that allows operations on pods. And what we want to, and basically this is a read-only access to that pods, because we can get the pod, we can watch the pod and list the pods. So listing is, about getting the list of pods in that namespace. Getting is about describing a specific node. And then we've got a watch, which is a special command in Kubernetes that allows us to wait until something changes in the pod. Watch is especially useful when we are writing a controller, or maybe using some kind of application that want to get notified about the changes. You also need to be aware that there are some kind of meta resources here. So basically you can write, for example, pods/logs, and this way you will allow or access to logs of a specific pod, for example. So this is about the role. And then we have something called role binding, and role binding is something that tells who actually can use the permissions from that role. So we've got some kind of subject here. As you can see, we've got kind user. And what does it mean? I said that there are no user objects. However, we are referring to something like that. It's kind of dynamic object inside the Kubernetes, because the name here, Jane, Kubernetes will get it from the token. So if you are using, for example, JWA token, it will look for in the subject field and then map that to the name. If you are using a client certificate, it will use something called common name from the certificate to assign that specific name. And by using that, we are just telling that, oh, actually I've got wrong references, but we are telling that this specific subject, this specific user can actually refer to our role reference. So this is it. Let me quickly fix that highlighting over there so I can show you better what I have on my mind. Let's refresh my browser and it should be, yeah, it's working. So the second important section over there is role reference, and role reference is actually specifying what specific role can be used by the subject we specify over here in the previous step. So basically we are telling that by using that role binding, we want these users to access a role called pod reader. In which namespace? In this namespace, because for regular roles and role bindings, it's always referring to the roles inside the same namespace. There's no way to actually create a cross namespace role binding. In that cases, you just need to create a role also in another namespace and then create another role binding in that namespace. There is no way to create like that. Or if you need to access any kind of namespace, then you are creating a cluster role and cluster role binding, which are basically the same, but this way you don't need to specify a namespace. And last thing here, this is the example of applying a service account. So here we are specifying that service account can basically access our role as well. And there is an exception here, as you can see. For service accounts, we can create and specify the namespace the service account is in. So basically, you can use here a cross namespace reference. So this is kind of important because there are cases that you want one applications to access multiple namespaces, and this is basically it. Okay, so this is all about role binding. Before we move on, let me show you some kind of roles. So as you can see, I've got a couple of roles created in my cluster. They are created in the couple of namespaces, two namespaces to be more precise, kube public and kube system. And there are, kind of roles that were created by default. If we go here, we can see the details, the YAML file with manifest of that role, and we can see that, for example, that role can operate on config maps, and it's working like that. Then let's see role bindings. You can use, the shortcodes. RB is for role bindings, so this is quite useful to know that shortcut. And as you can see, we've got a namespace on the left. Then we've got a name for the role binding. Then we've got some kind of role that is referring here. And then we can see who exactly can access that specific role. So here in the subjects, we can see SVCA, ACCT, it's service account, of course. And then we've got some kind of user. Here we've got K3S Cloud Controller Manager. And here you can see all the things related to that. As you can see, I don't know why K3S is using user for that thing instead of service account, but they probably have some reasons for doing so. On the other hand, let's see cluster roles. As you can see, there are a lot more roles. For example, we've got something that is called traffic kube system. This is, a role used for my ingress controller. Let's go here. And as you can see, this is a cluster role because my traffic application wants... oh no, I, of course, forgot to that. You should, unfortunately, there's a delay between what I'm telling and And what you are seeing, there's about 1 minute of delay, so I need to repeat my previous 2 minutes of talking, but sorry for that. Again, I need to sticky note over there. Okay, so we've got a list of roles here. I put a colon and then role. And you see there are some kind of roles in my cluster. We can press Y, and then you see that, for example, this role has a read-only access to secrets. I see that based on the verbs here. And then let's see another role, for example, this one. And this one, as you can see, has access to multiple things. For example, it can read config maps. It can update config maps, and it can also create events. So basically, many applications, want to also write something to that global log of Kubernetes that is called events. And this is not actually a log, but it works similar to that. And as you can see, that application wants to create events in clusters, so you can see them. Then let's go to cluster roles. As I mentioned before, I'm using CR, which is a shortcode for a cluster role. And by pressing CR and going over there, I'm here in the cluster roles. And I can see that, for example, my traffic, which is an ingress controller. Maybe first let's show YAML version. My traffic needs to, watch all ingresses and ingresses classes across the cluster. So basically, that's why it's a cluster role, not a regular role. And you can see it also needs to access secrets, so it can read TLS certificates and do a couple of other stuff. K9s is kind of nice, because if I press D, then I've got, some kind of summary for that. So you can see that here I've got a list of resources that are specified within the rules, and here I've got verbs that are associated with the specific role. So I can quickly examine what exactly it can do. So this is like that. Let's go to another example. For example, this is a role for administrator. So as you can see, administrator has full access to almost all things in the cluster. There are also some kind of not very obvious one, like impersonate, where you can impersonate, and by that I mean assume the identity of the service account. But this is other stuff. This is quite advanced stuff. What else I want to show you? Yeah, so it's working like that. Of course, we've got cluster role bindings. This is, about binding a specific users to a specific cluster roles. So for example, you see here that we've got a cluster binding, and we can describe that, and we see that there is a group called system masters, and that group is basically has all access to the cluster because it's assigned to the cluster admin. And by the way, we've got also a concept of group in Kubernetes. I don't have that on my deck because probably it's not covered in CKAD, but I want to mention about that. So basically you've got some kind of groups, and you can, for example, specify a couple of things here in the group. There are, a couple of policies inside the group, and as you can see, and the policy specifies what exactly is there. I don't want to dive deep into details because, this is also kind of dynamic stuff, and also there are, a couple of levels of authentication. For example, you can aggregate multiple groups, aggregate multiple roles, and it's getting quite of complicated, so I don't want to dive deep about that, but you should be aware that there is also a concept of groups, and they may be useful for you in the future. So this is basically it regarding the role-based access control. It's kind of hard at the beginning to understand how it's working, and it's also sometimes quite hard to troubleshoot that because The only way to know that something is forbidden is probably through the logs of the application. When you see that something is not allowed on the Kubernetes API, then it means that probably you are lacking some resource or lacking some verb inside your role. However, the error messages from Kubernetes API server are quite obvious, so fortunately it's quite quick to troubleshoot. Okay, let's go to last topic for today, and this is understand service accounts and service security contexts. So basically I covered service accounts in the previous chapter. So let's talk a little about security context. So basically a security context is all about privileges for pods or container. It can work on two levels. One is on the pod level, which is obviously applies to all the containers, but you can also set some kind of privileges per container, so you can make some of the containers more powerful than others. And by using security context, you can limit things like you can set and enforce user ID in which the processes are running inside the containers. You can also apply, of course, a group ID. You can set things like Linux settings, labels and other stuff related to that. It's also possible to set things related to AppArmor, which is an alternative to, let's say, alternative to security enhanced Linux. And then you can also set if the container is privileged or unprivileged, and by that I mean if it can, has some kind of capabilities. In that case, it's capability of admin. We can also, if we don't want to set the container, to have all capabilities on the system, we can add or drop Linux capabilities, one by one by name, and this way we can, for example, allow a container to manage hosts network interfaces. This is especially useful if you are using container network interfaces, for example, like Calico with or something like that. They usually have that permissions, to manipulate host adapters and host networking, and this way, by using capabilities, you can ensure that they don't have any, the full access to the system, but only the net capabilities related to the network adapters. This is also nice thing. You can enforce read-only file system from container. Why I like it? I like it because this way you can ensure that application is not writing anywhere in the container. It can only write to the volumes that you mount to it. And this is, really nice because you don't get out of the, disk space that you are not monitoring or something like that. And it's also more secure because you know that the application is not making any kind of dump, creating any kind of cache files or other things. You also need to know that basically, if you are using a root directory or file system of the container, is less performant than the volumes. For example, even if you mount empty dir volume to your container, it's usually more performant than a native file system for the container because it's overlay FS and basically it's built of multiple layers. So when you are actually writing something to them, it's kind of hard and less performant for operating system to perform that operation. Example of security context. Here we've got pod level security. As we can see, we are on the first level of specification over there. And here we are enforcing that the pod will be run as a user with ID 1000, as a group 3000, and there is also on the line 9 something called FS group. Here we are basically allowing to access also files with the group 2000. And let's go here. Here we've got an example of container, and then we've got security context. And here we are telling that we don't allow any kind of privilege escalation. So basically it's not possible to run run a container or run a process inside the container with more capabilities than the pod container, the pod process. I mean the process that is running a pod, to be more precise. Okay, so this is it. It's kind of important stuff, however, quite kind of quick. Usually you don't have to focus a lot about it. Usually you focus on that when some kind of compliance is in your project and you've got some kind of automated scanners that, you know, checking that are checking that stuff and enforce that stuff on the cluster level. Then usually you should implement that. But I highly recommend to implement that always, especially the one with read-only file system. Okay, so what else we have for today? The last topic, this is the last topic, not the previous one, and it's related to requesting, limiting resources, setting the quotas, and doing a couple of nice stuff. From the perspective of the administrator, this is very important because it has direct impact on the cluster stability and reliability. But we will go to that in a minute. Let's first talk about what are the limits and what are the requests. I mentioned shortly about that in one of the previous meetings. However, let's talk about it again. So basically by using requests, you are telling Kubernetes about the requirements of each container. You can say that, this Java container, it requires 2 gigs of RAM to run, and then you can set limit for that container. For example, my application never exceeds 4 gigs of RAM. So I want to have a limit on that because, you know, if my application exceeds that amount, there's probably something wrong. So I've got some kind of leak, or I don't know, garbage collector has died or something wrong has happened, and then Kubernetes should step in and do some kind of intervention. We can also enforce some kind of limits on the pods and on the containers. And it can be used, for example, for fair usage. So if we've got multi-tenant clusters, or we host the cluster for multiple teams or multiple developers, then it is possible that, you know, some application can get more resources, or even, you know, has some kind of bucket to exhaust and use all resources that are in the cluster. And by using limits especially, we can ensure a fair usage. For example, we can allocate some kind of CPU and some amount of CPU and some amount of memory to that application. And this way, you know, application cannot exceed that when it's under pressure of resources. By using requests and limits, we also help autoscaling of the cluster, processes related to autoscaling of the cluster. Autoscalers in Kubernetes usually work in the way that if they see that there is a pod that is unscheduled because of the lacking resources, they start another node in the cloud, and in a couple of minutes the node is ready, and then the pod is schedulable. However, it's not always the case, because if you are not using any kind of request or limits, then a cluster autoscaler does not know, you know, how big the node should be, how much memory it should have, and other stuff. So it's kind of good practice, and I highly recommend you to always mark requests and limits when you are using autoscaler. It really matters in the cloud, not so much when you are using Kubernetes on-premise or maybe at the edge, because this way you cannot autoscale easily. But if you are using cloud and autoscaling, then it makes sense. Okay, how it works like. As you can see here, we've got a sample pod definition. And as you remember, we've got a container section, and we can just go here and specify resources. All of that fields are by default not required. You can skip the whole resources section. You can skip request, limits, it doesn't matter. But if you specify them, they are applied to the specific container. So this is one thing. And as you can see, I'm here requesting 46 megabytes of memory, and then a quarter of CPU. This is, you know, 1/4 of a physical or virtual CPU, depending where it's running. And then I also want to limit my application to 128 megabytes, and then half of the core of CPU. So if you were following me in one of the previous meetings, I already mentioned that for memory and for CPU, it works a little bit different. For example, here limit for CPU is not, hard limit. If there are resources that can be used, the application will get as much CPU as it requires. So basically, Kubernetes is not enforcing that constantly. The limit takes place, enforcement of that limit takes place only when there is a pressure of resources. So if, for example, all applications of the cluster are requesting CPU, then Kubernetes will enforce that amount of CPU for that specific application. On the other hand, it works a little bit different from memory, because if a process exceeds memory here, specified in the limit section, then Kubernetes will kill that process and restart that container. And you need to be aware that, because out of memory kills is one of the most common thing when you are using limits. So it's kind of important to have something in place for monitoring the actual usage of resources. I'm looking for one thing here in background. There is a project from Cloud Native Computing Foundation. It's currently over there, and it's called Goldilocks, and basically it's all about generating recommendations. So basically there's something called Recommender, and it works with vertical pod autoscaler, and you can use that specific project for finding a proper amount of resources you should assign to your specific pod. I pasted the link in the chat. And one last thing related in that example, you should take into account that there may be multiple containers inside your pod. So you need to, calculate all the resources based on the total pod amount. It's especially useful, if you've got resource-hungry applications that requires, multiple gigs of RAM within the single container, because simply if you request too much and no node can provide that amount for resources, then pod will be unschedulable. So, and you will be in trouble. Okay, resource quotas. So basically we talked about limiting and enforcing some limits on the pod and container levels. There is also something called resource quota, and this way you can enforce some kind of limits per namespace. So how it looks like, you are creating a resource quota object in the namespace. Administrator is creating that, and administrator is not allowing anyone to tamper that resource quota. It's using airbag, of course, and for example, allows user to only do deployments and pods and other stuff, but do not edit or delete resource quota. And then when the resource quota is in place, the user has to specify the requests or limits for the pod that they are requesting. So basically, by using resource quota, you are enforcing to use that. But if your users don't want to specify that in all cases, or you've got some kind of, dynamic environment where some containers are generated, for example, if you are using service mesh where usually sidecar container are added in a dynamic way, then you can use something called limit ranger that will set that the values by default for you. And by using resource quota, you can also limit the number of objects per namespace. So, for example, you can say that this user, not this user, but all the users allowed to create in that namespace can only create, 25 pods in that namespace in total. And this is an example of resource quota for CPU and memory. As you can see, by using that resource quota, we can limit the amount of memory that we want, we may create a pod with. So let's maybe do a quick demo. Let's go monitor, yeah, change the screen. Now I remember. Okay, let's create object like that. So basically I'm creating, I'm pasting the contents of that resource quota, then applying that file, resource quota, over there to my cluster. I've got probably some kind of error over there. Resource quota inversion cannot be handled as the resource quota quantities match regular expressions. Okay. So probably I need to just, put that in that way. And I think it will just run fine. Must match regular expression. Okay. But which one? Let's do it like that, maybe. But now I is actually allowed as well. Okay, let's go one by simply, commenting out and checking what is working or no, not. Let's see. If you have any idea how can I fix that, then I will be glad, because after whole day I'm not thinking that fast. Let's see, like that. Maybe it works. Nope. I have no idea, to be honest. Let me quickly Google that. Give me 2 minutes. And we will see how people are using that. Sorry for that. I should check that. Oh, okay. I see. People are using something like that. Let's see if it works. Yeah. Okay, so basically you need to do something like that. I was writing that example. Okay. We need to modify it to be that way. To be honest, I'm not sure why is that. I mean, this is, equivalent syntax for YAML. I mean, you can both indent them as well as you can put that with dots. Requests. Yeah, okay. And then we've got that resource quota configured. Let's go here and see how it looks like. Okay, and we've got our resource, and as you can see here, we can monitor what exactly is the quota usage. So as you can see, we've got request of CPU 0 out of 100 M, which is 1/10 of CPU. And then we've got the same for limits. We can monitor that, if we were about to create some kind of sample pod. Let me quickly create, I've got example of pod over there. Let me quickly create a pod like that. There is a pod copied from the internet. Looks good. And then, I'm applying that to the cluster. It's forbidden, and as you can see, I'm exceeded the quota probably for my pod, or to be honest, I haven't specified an amount of memory that my pod uses. And as you can see, we've got an error from that resource quota. If I edit here my pod definition and then provide some kind of memory like 7 megabytes. I don't remember that quota. Let me quickly see the resource quota. Yeah, it's 2 gigs, so it should be fine. I've got 750. And then I should be able to create a resource because, I specified both the things that were requested by my resource quota. And now, as you can see, my resource quota changed over there. As you can see, I'm using all my assigned requests and some of the limits for my pod. So let's copy that pod as pod to YAML and then create the second copy with different names. So you will see that Kubernetes will forbid me to do so because I'm exceeding the quota. So as you can see, I'm creating a pod 2, but I exceeded the quota for my pod. So it's no longer possible, to use more resources. So this is a perfect way if you get a shared cluster that multiple people and multiple team uses. You can also limit multiple tenants by things like that. So this is a kind of nice approach, and I really recommend for you to set that on your clusters. Okay, let's go to the last topic for today. Maybe not the topic, but last thing for today, limit range. So basically the last object I'm going to talk about is something called limit range. It enforces compute resources. So basically, as I said, there's a couple of use cases for limit range. The first one is you can set default values for things like CPU and memory. So if I were not specified that inside my pod, then the limit range steps in and then sets the default for me. But you can also do a couple more things. So for example, you can also enforce some kind of minimum and maximum values for each of that thing. So I can set that, for example, memory usage cannot be lower than half a gig and then higher than 2 gigs. So I can be very specific about that. I can also enforce things like CPU, of course, as well as this is important ratio request to limit, because there is a possibility that someone requests a very low amount, but then has a very high limit for resources. And this way, cluster autoscaler cannot work efficiently. So we can, for example, enforce on the namespace that limit cannot be, bigger than 2 times request. And this way we've got, some kind of range that we can work with in order to optimize our autoscaling operations. And this is example limit range. As you can see, I'm here specifying a couple of things. So this is a default limit. I'm telling that Kubernetes that if a user has not specified a limit for pod, then use 500 M. So this is half of the virtual CPU. The same for request. And here I've got 2 settings related to CPU. So I'm basically telling that user cannot use more than 1 CPU per container. So as you remember, resource quota limits as per namespace, but here with limit range we can do it on the container basis or also on the pod basis. So we can say that, for example, a single pod cannot use more than this amount of CPU or this amount of memory. Or single container within the pod. So this is, quite elastic. If you've got very special cases, you can, fine tune that limit ranges, and they will work just fine, and and keep track of all resources. So this is quite nice, I can say, especially in multi-tenant environments. Because there are a couple of approaches to Kubernetes. Some people like to create a big cluster and then manage multiple tenants on one cluster. On the other hand, you can create multiple clusters per tenant. To be honest, I prefer that structural approach, so creating multiple cluster, each one for each tenant. However, it's different depending on the case, so you should consider that. Okay, and basically that's all for today. If you've got any question, just write them down. And next week we are meeting for our final meeting related to services and networking. I think it will be quite interesting topic. Of course, we won't dive that deep as I wish to dive, I can say, because networking is a very fascinating thing in Kubernetes. There are multiple levels of abstractions and things are working so nice. But we will cover only the basics required for the exam. And I hope that will be just enough. So if you've got any questions, you can write them down. If not, just give a thumbs up, subscribe if you haven't, share with your friends. Maybe someone will be interested in my channel, especially that next week I hope to start my home lab series, a series of videos. Basically, I bought a server and doing some cool stuff there, including testing of different Kubernetes approaches. So I think it will be quite nice. So I will wait a minute for potential questions. And if not, then, then we will see next week. Thank you. I've got a comment that it's very interesting webinar. That's nice. That gives a satisfaction, after a couple of dozen minutes of preparation of decks. That's good. Okay, I see there are no questions over here. So thank you for today's meeting and see you next week. Bye. Have a nice evening.